Hello. In this video we are going to look at how to conduct a multinomial hypothesis test for the chi-squared distribution for the claim that four categories occur with the following frequencies. The null hypothesis is that the probability of the first category, A, has a probability of 0.3. The probability of the second category is 0.2. The probability of the third the third category is 0.3, and the fourth is 0.2. It's asking us to complete the table. We have a number of observed frequencies here, so we should take note that the sample size, n, is 40 plus 22 plus 26 plus 20. So in our Geogebra, by the way, I'm using geogebra.org/classic for these calculations, mostly because I also want to show the hypothesis test, and the classic calculator has the hypothesis tests in it. So really quick, we'll do 40 plus 22 plus 26 plus 20. Press enter, and we will have a total of 108. Oops. For the expected frequencies, we are going to do n times p for each category. So in this case, we'll have 108 times the probability from the null hypothesis of 0.3. So 108 times 0.3 is 32.4. Then we'll do 108 times the probability of the second category, 0.2, would be 108 over 5. Press the little the blue button on the right, and it'll give us the decimal equivalent of 21.6. And then it just so happens that these values will repeat. 108 times 0.2. But if you needed to do other calculations, you could do other calculations. Now, to find the squared residual, we need to use the formula O minus E squared over E, or the observed minus the expected squared over the expected for each of these categories. I'm going to zoom in a little bit so you can follow along with what I'm doing here. So for the first one, for A, we will do 40 minus 32.4 squared over 32.4. For B, we will do 22 minus 21.6 squared over 21.6. For C, we will do 26 minus 32.4 squared over 32.4. And for D, we will do 20 minus 21.6 squared over 21.6. So just bear with me a second while we do these calculations. Close parentheses, or use the right arrow, press squared, divided by 32.4, enter. We'll get 1.78. I know the question is asking for 3 decimal places. I don't know how to change that in the classic view. Give me a second. Alright, so I had to choose settings over here, and then I'm not sure what that is. I had to go to rounding, and we could choose to round to 3 decimal places. So I also had to go full screen in order to find all of those. So now we are back. Let me just, oh, that's not what I wanted. I want to move this one. Oops, come on. keep on working on this. So now this is 1.783. So you can just kind of hang out and watch, or you can skip ahead to when this is complete. It's going to take me a few minutes to finish typing all of these in. .264, and then lastly parentheses 20 minus 21.6 squared divided by 21.6. Convert this back to a decimal, get 0.119. So the chi-square statistic is the sum of these chi-square. So all we're going to need to do is add up all of these values. What's really nice about Geogebra is that all of these values now have a specific letter associated with them. So G, F, E, and D. So I could type in 1.783 plus 0.007 plus 1.264, or I could just do D plus E plus F plus G and press enter, and I get 3.173. But I also wanted to show how we could do this using the hypothesis test built into Geogebra. Again, we're using the geogebra.org/classic website for this. If we click on the hamburger, we can then select perspectives and choose the probabilities perspective. And from here, we can click statistics, and statistics will bring up our hypothesis testing menu. And we can choose the goodness of fit test to see whether or not our hypothesis test here fits the expected or the supposed hypothesis test, or multinomial distribution. So we have 4 rows, A, B, C, and D. We can type them in here if we want to. A, B, C, and this step here is completely optional, but since I'm making a tutorial video, I figured I'd show them. So for the observed, we're going to put 40, and then 22, and then 26, and then 20. And in the expected, we're going to put all of these black numbers, 32.4, 21.6, 32.4, and 21.6. I believe we also could have changed this to be 108 times 0.2. And we could have just typed those in right into here as well. So from here, I am not able to show the full screen. What if I go like this? Nope, still not able to show the full screen. If I press this button, still cannot show the full screen. Alright, so this is not super fantastic like I was hoping it was going to be. I guess if I hold my screen sideways, it will now show the full screen. But the viewing window is not where I want it to be. Alright, this is not going the way that I thought this video was going to go. I apologize for that. On the bottom, we will see that the chi-squared value is 3.173. And the p-value will be given to us, but we just cannot see it. How do I do this? Nope, don't want to do that. All right, well, hopefully you followed along, and hopefully you were able to figure this out as well as me. I have it on my screen. You have it on your screen.